Hi everybody, here is a review package for our Unit 5. I thought I would go through this with you. And I will send you the Unit 5 test soon, which will look very similar to this. And I will get you to complete that and send it back to me. But for today, let's do an answer key for this. Unit 5 review assignment. Okay, and so remember this unit is on all types of equation solving, rational, radical, and absolute value, and then there's some stuff at the end that we did at the very beginning of the unit. Okay, so let's solve some equations. Number 1, the square root of m is equal to 9, so that is a radical equation, and what you're supposed to do is get the radical by itself and then square both sides. So the radical is already by itself, so you go square both sides and we get m equals 81. And then I would plug 81 back in there. Is the square root of 81 9? Yes, so that one works. I'm going to go back and forth here. Why don't we try number 5 here? Let's get the radical by itself. Over here we would have negative x minus 1. And then square both sides. And we get x plus 1 is equal to I'm going to have 2 brackets of this. So I will end up with x plus 1 equals x squared. And then we'll end up getting plus x and plus x, so plus 2x, and then negative 1 times negative 1 is plus 1. And I'm going to collect like terms. That will be 0, and then x squared plus x, and that will cancel. So we'll end up with x squared plus x equals 0. That's a quadratic, so we can try to do it by factoring or quadratic formula. It does factor by GCF. And we get an answer of 0 and negative 1. And when you go back and check these, the 0, 1 doesn't work, but negative 1 is good. So we have to reject 0, and our final answer is x equals negative 1. Okay, let's try number 2. We have to get the radical by itself first. We have the square root of 3n equals 6. Then we can square both sides. Divide both sides by 3, and we will get n equals 12. Does it work? 12 times 3 is 36. The square root of 36 is 6. 6 plus 12 is 18. That one works. Good. This one, we will subtract 13 from both sides, and we will get negative 13 equals 6 times the square root of x. And that's not going to have a solution, right? Because anything that comes out of the square root is positive. Positive times 6 is not going to equal negative 13, so this one has no solution. How about number 3? First of all, we would have to multiply both sides by the square root of m minus 3. So we get 5 times the square root of m minus 3 equals 2 on this side. And then you could divide both sides by 2 if you want to get the radical completely by itself. Okay, and then square both sides. And we get m minus 3 equals 4 over 25. And then add 3 to both sides. So m is equal to 4 over 25 plus 3. Which is that, and we'll go, excuse me, math, fraction that, 79 over 25. Okay, and that works in the original equation because it's 2 divided by the square root of m minus 3, and m is 79 over 25. Minus the 3, close the bracket, that's supposed to equal 5. Boom, we got it. Okay. Number 7, square both sides, because the radical is by itself already. We end up with 44 equals 7g. Divide both sides by 7. G is equal to 44 over 7. Okay, when we check that, that one is good as well. Okay, so just imagine going the square root of 5 plus 7 times 44 over 7. That has to be under the square root, and this has to work out to 7 according to the equation, which it does. Okay, how about number 4? The radical is by itself, so we can square both sides. And we get y plus 2 equals y squared, so that's a quadratic. So set this equal to 0 and solve. Y squared minus y minus 2, and then see if we can do this by factoring. Plus 1 and minus 2, I think it is. Yep, that looks good. So the answers are negative 1 and 2, and we have to see if we need to reject any. We're going to have to reject negative 1. So that one gets rejected. If you go and check it in the equation, it doesn't work. 2 works, so y equals 2 is the answer. Alright, this one here, let's get the radical by itself first. We have 6 equals the square root of p squared plus 5p, and then square both sides. So we get 36 equals p squared plus 5p, and since it's quadratic, set it equal to 0 and solve by factoring or quadratic formula. P minus 4 times p plus 9. So the answers are possibly 4 and negative 9. Okay, and they both work. Go and check them back in the equation. Number 9, let's get the radical expression by itself first. So add 10 root c to both sides. We have c plus 9 equals 10 root c. Okay, when there's a number multiplied out front, we don't really have to get rid of the 10 there before we square both sides, because squaring it looks like this. C plus 9 squared is c squared plus 18c plus 81. 10 squared is 100, and the square root of c and then squared would just be c. (18c) take away 100c is negative 82c plus 81 equals 0. Does this factor? Yes. Minus 81 and minus 1. So, possible answers are 81 and 1. Do they both work? Yes, they do. You can check them out. Okay, now I'll do number 13 here. It's a rational equation. The non-permissible values are a cannot equal negative 2, The lowest common denominator is 4 times a plus 2. And so that's what I'm going to multiply onto both sides. And on the left-hand side, the a's plus 2's cancel. You get 4 times 3 is 12. And when you multiply that onto a over 4, the 4's will cancel, and you'll have a times a plus 2. And then the 4 times a plus 2 multiplies onto the negative 1 and becomes negative 4 times a plus 2. And now we solve this for a. That will be minus 2a minus 8, subtract 12 from both sides, and we will get 0 equals a squared minus 2a minus 20. Try to do this by factoring. Two numbers that multiply to negative 20. Multiply to negative 20 and add to negative 2. This does not factor, so we actually have to do the quadratic formula. It would be the negative of b plus or minus the square root of b squared minus 4 times a times c. Okay, I'm kind of running out of room there. B squared minus 4 times the a number is 1 and c is negative 20, all divided by the a out front here, 2 times that a. So if you do this, you end up getting a equals 2 plus or minus the square root of 84, all divided by 2. And then the answers end up being 5.6 and negative 3.6. And neither of those conflict with the a cannot equal negative 2, so they're good. Awesome, let's check out number 10. Square root of something equals the square root of something else. So just square both sides. And we get x squared minus 3 equals 3x plus 1. Subtract 3x, subtract 3x, subtract 1, subtract 1. We have x squared minus 3x. Those are unlike terms. Negative 3 minus 1 is minus 4 equals 0. And this factors into x plus 1 times x minus 4, and we get x equals negative 1 or 4. The negative 1 creates negatives underneath the square root, so we have to reject that one, and so the only answer is x equals 4. All right, number 14, we have 6 equals k plus the absolute value of negative 4 is 4, and then subtract 4 from both sides, and we get 2 equals k, and we're done. Let's try number 15. The a plus 4 could equal 8, or the a plus 4 could equal negative 8, in which case we're going to get a equals 4 over here, and a equals negative 12 over here. Do they both work? Yes. For number 11, w cannot equal 0. The LCD, something that 3 and 5 and w all go into, would be 15w. So that's what we're going to multiply both sides by. Okay, and in the first situation, the w's will cancel. You'll have 15 times 2, which is 30. And then we're going to get a negative result, positive times negative. 5 into 15w is 3w, times 2 is 6w. And then 3w into 15w is 5, and 5 times w minus 1 would look like that. Right-hand side is 0. This will be negative w plus 25 equals 0. So negative w equals negative 25, and so w equals 25. Again, that doesn't conflict with w not equaling 0, so that's a good answer. Okay, how about number 12? M cannot equal 3 or 0. And the LCD is, I'm going to need a little bit more space for the LCD. We need 20, and we need m, and we need m minus 3. So both sides are going to get multiplied by that. Okay, and on the left, when this whole term multiplies onto that, the m minus 3's cancel, and we will get 60m. Minus sign. 20 into that LCD will knock off the 20, but it will leave the m times the m minus 3 multiplied onto the 1, which will leave that, equals, m's cancel, we will have 60 times m minus 3. And then it just becomes a small equation to solve. It's going to be minus m squared plus 3m. This is 60m minus 180 when you do distributive. So we have 63m minus m squared equals 60m minus 180. So I'm going to subtract 63m from both sides. And I will have minus m squared equals negative 3m minus 180. And I just need to add the m squared over. And we get 0 equals m squared minus 3m minus 180. And I think this factors into m plus 12 times m minus 15. I think 15 times 12 is 80? 180? Yes, good. So the solution is negative 12 and positive 15. Okay, and neither of those conflict with the non-permissible values, so they look good. Number 16, we've got 8 plus 9, and we've got this negative in front of this absolute value. 8 plus 9 is 17, equals 10. Now I'm going to subtract 17 from both sides. Minus 17 is negative 7, and now we can divide both sides by this negative 1, and we will get 2y, absolute value of 2y minus 5 equals positive 7, and we can get two equations coming out of that. So 2y minus 5 equals 7, or 2y minus 5 equals negative 7, and solve these separately. 2y is equal to 12, divide both sides by 2, and y is equal to 6. We need to check that. And the other one, we get 2y equals negative 2, divide both sides by 2, and we get y equals negative 1. And I think they both work, but make sure you double check in the original equation. This one definitely works. And negative 1 works as well, so they're both good. Okay, number 17. The non-permissible values are y cannot equal negative 8 or positive 2. The lowest common denominator is y plus 8 times y minus 2, and we multiply both sides by that. I'm going to have to move this out of the way. Y plus 8 times y minus 2, and let's just put the non-permissibles down below here. Y cannot equal negative 8 or positive 2. Okay, so when we do our multiplication onto both of these terms, in the first situation, y plus 8 is going to cancel, and you have 3 times y minus 2. In the second situation, when we multiply it onto the negative 2, there's nothing below the negative 2, so nothing cancels. So both of those brackets remain. Equals, on the right-hand side, the y minus 2's cancel, and you have 4 times y plus 8. Okay, and then it's a normal equation from there. Expand all brackets, collect like terms, isolate the letter. 3y minus 6. We have a minus 2 sitting in front of this. Two binomials multiplied together, so we have to do FOIL. And we are going to get y squared minus 2y plus 8y minus 16. Right-hand side, we do distributive and get 4y plus 32. So we have 3y minus 6. I'm going to multiply this negative 2 through and go negative 2y squared. And notice negative 2y plus 8y is 6y times the negative 2 is plus 12y. So I'm just doing a couple steps there. And negative 2 times negative 16 is plus 32. Okay, let's collect like terms. We have negative 2y squared. There's only one y squared term. We have 15 y's. And negative 6 plus 32 is 26, equals 4y plus 32. Now go subtract 4y, subtract 4y, subtract 32, subtract 32, and we have negative 2y squared plus 11y minus 6 equals 0. Oh, I did something wrong, I think. Yes, I did. I did something wrong, so I am going to erase this. Sorry, everybody. This is going to be 3y minus 6 minus 2y squared. That's positive 6y times negative 2. That should have been negative 12y. And I had positive. And then plus 32. And then 4y plus 32. Okay, now we have negative 2y squared. And 3y take away 12y is minus 9y, so that deals with that. Negative 6 plus 32 is plus 26, equals 4y plus 32. Okay, now I'm going to add 2y squared to the other side. I'm going to add 9y to the other side, and I'm going to subtract 26. That cancels to 0, that cancels to 0, that cancels to 0. So we have 0 equals positive 2y squared plus 13y plus 6. Okay, and this factors into 2y plus 1 times y plus 6. And so the solutions are y equals negative 1/2, because you subtract the 1 over and divide by 2, and negative 6, and neither of those conflict with our non-permissible values. Good, how about number 20? Let's subtract 6 from both sides. Negative absolute value of m equals negative 15. Divide both sides by this negative 1. Absolute value of m is equal to positive 15. This means that m equals 15 or negative 15. Okay, how about 21? Why don't we divide both sides by this negative 1 first of all, and then we will get absolute value of 1 plus 4a is equal to 13, which means that 1 plus 4a could equal 13, or 1 plus 4a can equal negative 13. And in this one, 4a will equal 12, and a will equal 3. And in this one, 4a equals negative 14, and a equals negative 14 over 4, which is equivalent to negative 7 over 2. And they both work. All right, number 18, non-permissible values. M cannot equal negative 1, and it cannot equal negative 1/3. The LCD is 3m plus 1 times m plus 1, and we will multiply both sides by that. And on this side, those cancel, and you're left with 2m minus 1 times m plus 1. And over on this side, you get m minus 1 times 3m plus 1. And lo and behold, it looks like we just cross-multiplied. But really, we're multiplying both sides by a common denominator. So let's do FOIL. 2m squared plus 2m minus m minus 1. 3m squared plus m minus 3m minus 1. Now collect like terms. And collect like terms across the equal sign. Zero. M squared minus 3m. And solve this by factoring. So the answers are 0 possibly and 3. And those don't conflict with the non-permissibles, so those are good. All right, number 22. 3x plus 2 can equal 4x plus 5, or the other equation, 3x plus 2 could be the negative of that. Over here, x is equal to negative 3, which we will need to check. And this one, we will get 3x plus 2 equals negative 4x minus 5. Seven x equals negative 7. And so x equals negative 1. And let's check these. Negative 9 plus 2 is negative 7. We put 7 on that side. Negative 12 plus 5 is negative 7. This is no good. We have to reject this. How about negative 1? Get 1 on that side and negative 4. This one works. X equals negative 1 is good. Let's look at 19. P cannot equal 5. The LCD is P minus 5. So we will multiply both sides by P minus 5. Front door bomb. The P minus 5's cancel in the first multiplication, just leaving P. When you multiply it onto the 3, it becomes 3 times P minus 5. And then over here it cancels and you're just left with 5. So we have P plus 3P minus 15 equals 5. And we get 4P minus 15 equals 5. Add 15 to both sides. 4P equals 20. Divide both sides by 4, and P is equal to 5. Oh, but we said P cannot equal 5, therefore reject our only answer, so no solution. Okay, finally, last page here. Simplify each rational expression and state any non-permissible values. Okay, so let's factor first before we can see the non-permissible values. The top factors into x plus 3 times x plus 6. The bottom factors into x plus 3 times x plus 3. Divided by x plus 6 times x plus 2. And there's something wrong here. That's supposed to be a 15. plus 3 times x plus 5. Okay, so the non-permissible values, of course, anything on the bottom of a fraction that makes it 0. So x plus 3, x plus 3, x plus 3, negative 3 is a problem for all of those. And then we've got x plus 5, negative 5 is a problem. Okay, but notice that this is also a division sign, guys, which means we can't divide the first whole big fraction by this if that thing works out to 0. And this side will work out to 0 if the top works out to 0. So negative 6 is a problem and negative 2 is a problem. Because it makes this whole fraction on the right-hand side 0, and then you would be dividing by 0. So those are some extra non-permissible values. Now we can go, hey, x plus 3 times x plus 6 divided by x plus 3 times x plus 3. If you're dividing fractions, you invert and multiply, so you change it to multiply, and then you flip this fraction. And now we can cancel some common factors. That cancels to 1, that cancels to 1, that cancels to 1. Final answer is x plus 5 over x plus 2 with those non-permissibles up above. Simplify each radical expression. Remember, you just want to divide out the highest perfect square factor that we can out of 54. That would be 9. Square root of 9 times the square root of 6 plus 2 root 6 minus the largest perfect square factor that goes into 24 is 4. And over here, the square root of 9 is 3, so that's negative 3 root 6 plus 2 root 6. Square root of 4 is 2 minus 2 root 6. And the square root of 6 cannot be broken down anymore, okay, because 4 does not go into it. 4 is a perfect square. 2 root 6 take away 2 root 6 cancels. Our final answer is negative 3 root 6. How about this one? Subtracting rational expressions. Okay, so we already have a common denominator of 2x. So you just go 5x minus 7 minus, it's minus 2x plus 3, so the negative distributes and you get negative 2x minus 3. So we end up with 5x take away 2x, which is 3x. Negative 7 minus 3 is negative 10, all over 2x. And that's as simple as that gets. Over here, simplify this. We would have 15 plus 20 root 2 minus 9 root 2 minus 12 root 4. So it's 15 plus 20 root 2's take away 9 root 2's is 11 root 2 minus 12 times the square root of 4 is 2, which becomes 24. Okay, so then we'll have positive 11 root 2, and 15 take away 24 is minus 9. And letter C, adding fractions, so we need a common denominator. We need something that a plus 2 goes into, but also a plus 3. So we need both of those factors multiplied together to get our common denominator. And notice this a plus 2 is multiplied by a plus 3, so I have to multiply the top by a plus 3. And then this a plus 3 was multiplied by a plus 2, so multiply the top by a plus 2. And now we have a common denominator. a squared plus 3a, this plus sign is here, 3a plus 6. So we end off with a squared plus 6a plus 6. And finally, rationalize the denominator for this one. So you multiply top and bottom by the conjugate. It looks like the bottom expression, you just change the sign in between. And so then the top becomes 2 times root 3 plus 2 times 1. And the bottom, we do FOIL, right? Root 3 times root 3 is root 9. Root 3 times plus 1 is root 3. So I'm doing this. Negative 1 times root 3 is minus root 3. Negative 1 times 1 is minus 1. That's going to cancel. We can divide out a 2 on the top if we want. Well, I'm only doing that actually because the bottom is going to work out to 2. Two divided by 2 is 1, so our final answer is the square root of 3 plus 1. Okay, so that's a review of what we did in this unit. There you go, everyone. I'll send you an assessment for this unit. You can complete it, open book with your notes, and then send it back, and we will go from there. All right, everybody. I'll talk to you soon.